All right, so this is week 3 of understanding backpropagation and neural networks. This is going off of 3 Blue, 1 Brown's video on backpropagation intuitively. This is his third video in the series. So a quick recap right before we get into anything. The most important part of this video would be gradient descent, right? Which is basically the core learning. Um, right, so it's the weights and cost functions. Um, so basically, right, quick recap on what the network is doing. It's basically, um, one sec. Okay, yeah, so, okay, my bad. Okay, so the recap, right? So real quick, the system that he was looking at, right? It has the 3 layers, right? It's the input layer, the hidden layer, and the output layer. Um, and gradient descent, right? What I brought up real quick is basically just minimizing costs by updating weights and biases. Right. So basically, right here, we basically just got the important information, right? So what is backpropagation? It's an algorithm to compute how each weight and bias affects our output error, right? Essentially, it's the algorithm that computes the gradient of the cost function, right? Use the chain rule from calculus to propagate backwards, right? Adjust weights to reduce the costs. The gradient shows sensitivity of cost to each parameter, right? Weights and bias makes learning possible by informing how to update the network. So it determines how each weight and bias should be adjusted, right? So it helps decrease the error from predictions. So to break down, right, each training example suggests how weights and biases should change, right? Neurons with stronger activations influence adjustments more. So, and what is a cost function? It's the difference between prediction and desired output. Each training example affects weights and biases, right? Adjustments aim to increase the correct output of the neuron's activation, right? So we want it to be as correct as possible. Influenced by weight strength, neuron activity, and biases. And then it's inspired by the Hebbian theory, right? So neurons that fire together are wired together. Stochastic gradient descent, right? A full gradient computation is slow with large data sets, so faster and practical for real world training of neural networks. And what we were to summarize from the entirety of the video is that backpropagation computes how each training example affects the model. Um, Weights and biases are updated to reduce output errors. So this is before we dive into next week's stuff, right? Or this is what's connected to week 4. So this is right before we talk about the attention and transformers. I think in that video we did talk about um there's more like examples, right? So there was actual math in the video. But like one thing real quick is that to summarize it is that backpropagation is the algorithm that computes the crazy complicated gradient, right? Because if we were to think of if we were to think of the direction in like 13,000 dimensions, right? You know, think of all the weights. We wouldn't be able to do it, right? So that's what we use gradient descent.